Last time we defined ordinary differential equations. Today we will discuss some properties of ordinary differential equations. What is the order? Uh, what uh, what do we mean by linear, non-linear, or ordinary differential equations? So today we will discuss such things. So let's start with definition. So let's start with the definition of an order. So the order of the highest derivative in a differential equation is called the order. Okay, there is a noise. Is called the order of the differential equations. Don't worry, I will give examples so it will be clear. Equation. So the order of the highest derivative is the order of the differential equation. Let me give an example. So example first one. So let's look at this one, d square y dx square plus x square y cube dy over dx is equal to 5x. So this is a second order ordinary differential equation. So this is a second order because of this second derivative. So we have so this is, we can write it like this also, x square y cube y prime is equal to 5x. So recall that sometimes we write shortly as the second derivative as y double prime. So d square y dx square means y double prime. So this is a second order ODE. Okay, let me give another example. So let's look at this one. D to the power 7 dx7 plus sin x dy over dx to the power 8 plus d cube y dx cube is equal to 9. So let's look at this differential equation. So what do you think? Is it a 7th order or 8th order differential equation? So we look at the order of the highest derivative. So what is the highest derivative? We have the 7th derivative here. So this is not the 8th derivative. So this one, let me use the orange color. So this doesn't mean the 8th derivative. This is the 8th power. So this is a 7th, that is y. So this is a 7th order differential equation. So it is not an 8th order because it is the 8th power of the first derivative. So here this means that y prime to the power 8. So it is not the order. Great, I hope it is clear. Okay, I will let's continue giving example to make this clear. So y double prime y plus e to the power minus x. So what is the order of this differential equation? This is a first order, right? So this is a first order because we have only one derivative. Okay, let's look at this one. Y square dy over dx cube plus cosine 2x d square y dx square plus 4y is equal to 0. So if you look at this one, what do you think? Is it a second order or third order? Is it a second order or third order differential equation? So the question is this. So you can guess. So it is a second order, right? So this is just the power. This is not the derivative. It is just power. So that is why it is a. So it is a second order differential equation. Ordinary differential equation. We don't have any partial derivatives, right? We have only ordinary derivatives. Great. Okay, so now let's define linearity. So let me give the definition. So what is the definition? So a linear differential equation. So we will define nth order linear differential equation. So of order n. So we have order n differential equation. This means that the highest derivative must be dny over dx, and must be dny over dx. So in the dependent variable y, so which depends on x, and independent variable x. Oh my god, I hope everything is fine. X is of the form. So we have a specific form. So we have the coefficients are always depends on x. So dn power n plus a1x dn minus y plus an minus 1x dy dx plus an xy is equal to bx. Okay, that looks too tiny. Okay, I will clear them. Equal to bx. So where the coefficients depend only on x. Okay, let me write the formal definition. I will give examples, don't worry. It will be clear where the coefficients a0x, a1x, so where all the coefficients, okay, I cannot see my writing on the screen.